Long short-term memory, LSTM, deep learning method for intrusion detection in network security. Abstract: nowadays, large numbers of people were affected by data infringes and cyber attacks due to dependency on Internet. India is logger country for any resource use or consumer. Over the past 10 years, the average cost of a data breach has increased by 12%. Hacking in India is take share of 2.3% of global criminal activity. To prevent such malicious activity, the network requires a system that detects anomaly and inform to the admin or service operator for taking an action according to the alert. System used for intrusion detection, IDS, is software that helps to identify and observes a network or systems for malicious, anomaly or policy violation. Deep learning algorithm techniques is an advanced method for detect intrusion in network. In this paper, intrusion detection model is train and test by NSL-KDD dataset, which is enhanced version of KDD99 dataset. Proposed method operations are done by long short-term memory, LSTM, and detect attack. So admin can take action according to alert for prevent such activity. This method is used for binary and multi-class classification of data. For binary classification it gives 99.2% accuracy, and for multi-class classification it gives 96.9% accuracy. Keywords: intrusion detection, deep learning method, LSTM algorithm, network security, NSL-KDD dataset. Introduction. Security of data is very important aspect of Internet in recent years. For illegal right to use or information from network, intruder made an intrusion in system. An intrusion is nothing but attack, hacking, packet sniffing, or stealing of data. Attacks are an aim to tear down system privacy or networks in way to extort money, other malicious intentions, or acquiring essential records. Intrusion modify program, data, or logic in computer by the use of malicious code, resulting in difficulty of few consequences that can give and take the institute's private data to formulate it accessible for cyber criminal. Many different attacks come under cyber attacks, which consist of hacking of data, denial of services, malware, phishing, and theft. The percentage of cyber attackers or illegal activities increases in the world, and defender of cybersecurity are experience a lot of threats from these cyber attacker. It could probably leave into enormous and a major impact on human lives. For that to take security measures are important. And these measures can be done by intrusion detection system, IDS. Intrusion detection can be done by collecting of data packets, analyzing it and detecting any unwanted, suspicious, or malicious things in traffic to inform administrator. This device is prepared for securing our data from any attack or unwanted use. The digital world is especially vulnerable to security threats. Hackers are gradually more hacked websites for various reasons. That creates many security threats that had made numerous companies reevaluate their security measures. Hackers ascertain the loopholes in the website to break the system and achieve their offender ideas. Intrusion detection system, also known as security information and event management system. Two methods are generally used, i.e., signature-based and anomaly-based. And some types are based on network intrusion, host-based, perimeter, VM-based intrusion detection system. The system detect network, i.e., a data packet travels from one to another destination. This step is useful for protection of data, information, and other losses due to attack. The remainder of this proposed paper is arranged as follows. Section covers related work with intrusion detection. Section gives detailed description of algorithm used in the paper, which is long short-term algorithm, i.e., LSTM. Next section related to NSL-KDD dataset. Section includes proposed system description. After that, section having tentative results, and last one is the conclusion of paper in section 2 related work. This section includes recent development in intrusion detection system. Many methods of machine learning are used for detection of anomalies. As development in technology, the techniques also upgrade to accomplish requirements. And now those techniques used machine learning that converted in deep learning methods for more precision and accuracy. Anish Halima and Dr. K. Sundarakanthan 1 used SVM and naive Bayes method for intrusion detection. This paper shows comparative analysis of SVM and naive Bayes with the help of NSL-KDD dataset. Both methods used for solving the classification problem. Accuracy and misclassification rate get calculated, and on that basis SVM works better than naive Bayes. Normalization and feature reduction are also applied to make comparative analysis. Performance of model depends on accuracy. Main motive is to reduce false alarm rate, FAR, and to increase detection rate by increasing accuracy. SVM algorithm is used for image processing and pattern reorganization application. On the other hand, naive Bayes is used for statistical classification, which is based on Bayes' theorem. This system includes pre-processing of raw data, classification according to set of rules, and result evolution on the base of method used. Mohammed Ishaq et al. 2 used deep learning, which is an region of machine learning research. Deep learning approach is used to selecting a subset of relevant feature from unknown information. These types of property are useful in analyzing highly complex information to detect anomaly from data present on internet or web system. Deep learning method is used for feature extraction to reduce dimensionality of the dataset obtained from the web system. This paper used unlabeled training data and web system data are given to pre-processing unit, then this data is compared with the help of stacked denoising autoencoder. After this data will be split into attacking and normal traffic. Jin Yang et al. 3 proposed the method to address the challenge of unbalanced positive and negative learning samples. We propose using deep convolutional generative adversarial networks, DCAN, which allows features to be extracted directly from the raw data, and then generates new training sets by learning from the raw data. This paper applies long short-term memory, LSTM, to automatically learn the features of network intrusion behaviors. To remove such dependency and enable intrusion detection in real time, we propose a simple recurrent unit-based, SRU, based model. The proposed model in this paper was verified by wide-ranging experiments on the standard datasets for intrusion detection, which is KDD99 and NSL-KDD, that effectively recognizes normal and malicious network activities. It achieves 99.73% accuracy for the KDD99 dataset and 99.62% on the NSL-KDD dataset. Gozd-Karatas et al. For this paper aimed to survey deep learning-based intrusion detection system approach by making a comparative work of the literature. Contains three main components: data collection, feature selection/conversion, and decision engine. To extend the pliability of the system, rather than signature-based detection, it's required to implement the system as anomaly detection with a learning system. Therefore, during this paper, it's aimed to supply a brief survey of deep learning-based intrusion detection systems with the overview of varied aspects of intrusion detection and deep learning algorithms. Additionally, this work lists and provides details about some publicly available datasets with their characteristics and shortcomings. Dimitar Nikolov et al. 5 This paper presents the effects of problem-based learning project on a high school student in technology school. The intrusion detection system is predicated on a recurrent neural network classifier, namely long short-term memory units. The intrusion detection system, IDS, consists of three modules: monitoring, processing, and learning module. Learning module creates the LSTM recurrent neural network and finds the necessary structure, weights, and biases. For learning, the dataset consisting of system call sequences is used. Brian Lee et al. 6 This paper presents a comparative evaluation of deep learning approaches to network intrusion detection. The paper present a comparative evaluation of deep learning approaches to network intrusion detection. Their performance is evaluated using the network intrusion dataset provided by Knowledge Discovery in Databases, KDD. The results of the analysis between the deep learning models suggests that the utilization of deep learning in NIDS would be an appropriate solution to improving detection accuracy on unclean data. However, building an environment that is specifically designed for this purpose would go a long way to further improve and could greatly impact the decision on which model would work best in a given environment. 3. LSTM, Long Short-Term Algorithm. Long Short-Term Memory, LSTM, is special sort or superior version of a man-made recurrent neural network, RNN, architecture utilized in the sector of deep learning. LSTM has feedback connections and designed to avoid long-term dependencies. It can't only process data points, but also whole sequences of knowledge. For instance, LSTM is applicable to tasks like unsegmented data, connected recognition pattern, speech recognition, and anomaly detection in network traffic or IDSs, intrusion detection systems. A common LSTM unit consists 4 main parts: 1. Cell, 2. Input gate, 3. Output gate, and 4. Forget gate. The cell memories values over random time intervals, and therefore the 3 gates standardize the flow of data or information into and out of the cell. LSTM networks are complementary to classifying, processing, and making predictions based on time series data, since there are often lags of unknown duration between important events in a time series. LSTMs were developed to affect the vanishing gradient problem that can be encountered when training traditional RNNs. Relative insensitivity to gap length is a plus of LSTM over RNNs, hidden Markov models, and other sequence learning methods in numerous applications. LSTM having 4 stages in its cell structure as shown in Figure 1. In cell state, the horizontal topmost line running in cell that indicates cell state. The LSTM does have the ability to eliminate or incorporate information to the cell state, carefully regulated by structures called gates. The cell has series-like structure in it. Step 1. The first step in LSTM is to identify that information that are not necessary and make a decision of what information is going to throw away from the cell state. This decision is formed by a sigmoid layer called the forget gate layer. Fig.1, LSTM cell. Step 2. The next step is to make a decision what new information we're going to store in the cell state. This comprise 2 parts. 1. A sigmoid layer called the input gate layer decides which values will update. Second, a tan layer creates a vector of new contender values that could be added to the state. In the next step is to combine these 2 to create an update to the state. Equals H1 plus 2 equals tan. H1 plus 3. Step 3. It is now time to update the old cell state C, T1, into the new cell state. The previous steps already decided what to do, actually just need to do it. First, the old state multiplies by forgetting the things that we decided to forget previous. Second, then, add to cell state. This is the new candidate values, scaled by what proportion for decided to update each state value. Equals, asterisk, plus, star. 4. Step 4, final stage is output stage. This output are going to be supported our cell state, but will be a filtered version. First, run a sigmoid layer which decides what parts of the cell state going to output. Then, put the cell state through tan, to push the values to be between -1 and 1, and multiply it by the output of the sigmoid gate, so that only output the parts decided to. Equals, HT1 plus 5. H equals, asterisk tan, 6. For Dataset, NSL-KDD. Intelligent intrusion detection systems can only be built if there's availability of an efficient data set. A data set with a large amount of quality data which mimics the important time can only help to coach and test an intrusion detection system. The NSL-KDD dataset may be a refined version of its predecessor KDD99 dataset. In this paper, the NSL-KDD dataset is analyzed and wont to study the effectiveness of the varied classification algorithms in detecting the anomalies within the network traffic patterns. NSL-KDD dataset may be a dataset suggested to unravel a number of the inherent problems of the KDD99 data. This advantage makes it affordable to run the experiments on the entire set without the necessity to randomly select a little portion. Furthermore, the amount of records within the NSL-KDD train and test sets are reasonable. This advantage makes it affordable to run the experiments on the entire set without the necessity to randomly select a little portion. Consequently, evaluation results of various research works are going to be consistent and comparable. The NSL-KDD dataset has the subsequent advantages over the first KDD dataset. It doesn't include redundant records within the plaything, therefore the classifiers won't be biased towards more frequent records. There is not any duplicate records within the proposed test sets, therefore, the performance of the learners aren't biased by the methods which have better detection rates on the frequent records. The number of selected records from each difficulty level group is inversely proportional to the share of records within the original KDD dataset. As a result, the classification rates of distinct machine learning methods vary during a wider range, which makes it more efficient to possess an accurate evaluation of various learning techniques. The number of records within the train and test sets is reasonable, which makes it affordable to run the experiments on the entire set without the necessity to randomly select a little portion. Consequently, evaluation results of various research works are going to be consistent and comparable. Total 126,620 samples were available for NSL-KDD training module, along with 41 features each. Similar to KDD99, it will consider normal traffic or attack of special type. The features are categories as main 4 types. Basic feature: each resource obtained from the TCP/IP connection, such as service, duration, and protocol type. Time-based traffic features, such as RARA rate, SRV count, and count. Content features: in order to access the TCP packets, these resources use domain knowledge. Host-based traffic features: each attack longer than 2 seconds that share the equal destination host as the present connections are accessed utilized these kinds of features. The NSL-KDD labels are subdivided in 4 categories of attack and 1 normal traffic category. The attack categories are: DOS, denial of service, try to block network resources and / or services in network and computer network. Probe, attack that attempts to obtain information or find vulnerabilities in a network. R2L, remote to local attack that want to generate remote, non-authorized access to a network. U2R, user to root, special kind of attempts to obtain access as root user or admin. V proposed system. The paper used deep learning LSTM algorithm for detection of intrusion in network. This method has several steps as shown in Figure 2. NSL-KDD dataset is used for training as well as testing of LSTM model. The model used for 2 types of classification of output. One is for binary classification, that detect malicious and normal data for testing. And second is for multi-class classification of data, which give 5 output like DOS, U2R, R2L, probe, normal data. Fig.2, proposed methodology. Network Intrusion Detection System, IDS, dataset. There are many types of datasets available on Internet for intrusion detection in network. But the KDD99 dataset is most popular and mostly used by many researchers for their work on intrusion detection. The KDD dataset is used to modify the detection module, and many updated versions of KDD dataset is available for IDS. In proposed work, NSL-KDD dataset is used for detection of intrusion in network, which is newer version of KDD99 CUP dataset. A training/testing dataset. NSL-KDTrain and NSL-KDTest dataset is used for training as well as testing of LSTM model. It divided into 60:40 ratio, that means 60% of dataset is used for training and 40% of data for testing of model. The ration of training and testing can be varying according to researcher and application. B. Pre-processing. The pre-processing step is to produce data which is practical for detection of intrusion. Pre-processing mainly focus on the general operations, like converting the data into readable form and also into another format. Also eliminating the redundant data into dataset, this is taking from training dataset to model or test the data that is input data. This data is then given as input to the feature extraction for feature selection. Some of this having no values in columns that will be eliminated, to avoid confusion in learning as well as testing. This also includes normalization of data, which normalized values of matrix for LSTM model, to convert data into same format or type. C. Feature selection. Feature extraction is the process where important information. It is one of many factors which are used to increase the effectiveness of a detection system. NSL-KDD dataset having 41 features and 142 feature column is for data label. The 41 features are like as duration, protocol _ type, service, flag, etc. Last column, i.e. 42 column, is X-attack 17. This label converted into two categories. Binary classification, 0, 1, 0 equals normal traffic, 1 equals malicious traffic. Multi-class classification attacks were assigned with real values and new field called X-attack, DOS equals 1, U2R equals 2, R2L equals 3, probe equals 4, normal equals 5, unknown equals 6. D. Deep learning classification. By using LSTM deep learning algorithm, special sort of RNN, the data will classify into normal data, malicious/suspicious data, also in other attack types. 5 different types of attacks are included in this analysis: DOS, U2R, R2L and probe attack. Which type of specific attack occur on network, that also recognized by the algorithm for multi-class classification of data. E. Proposed output. The output of model gives two types of classification. This method gives binary and multi-class classification of test data. Binary class classification is used for binary output, which is for malicious and normal data. Multi-class classifier gives 5 output: DOS, U2R, R2L, probe and normal data. F. Output, network attack type. After classification, it gives output that detects network attack type. The deep learning algorithm is used for the detection of intrusion. If the malicious data is found, then the alert is given to the system admin to act according on the alert. G. Training values. The time requires for training or testing data is calculated as evaluation time of model. For binary classification or multi-class classification, training evaluation time depends on system parameters and specification. Because the deep learning is require latest specification for better executions of task. So, the evaluation time of testing or binary classification is 8.28 SEC and 3.25 SEC for multi-class classification. H. Performance statistical measure. The values are obtained from confusion matrix, used for calculation of different parameters. These parameters are nothing but performance measures of model. This section includes performance measure of binary classifier, which is having values for malicious data and normal data. And multi-class classifier, includes values for specific attack and normal data. Table I gives parameters for binary classification. 6. Experimental result. Confusion matrix. 1. Binary classifier. Data classification is performed by LSTM model for separating malicious data/traffic from normal data/traffic. Binary confusion matrix. Separate data into 4 parts, i.e. TP, TN, FP, FN. Green blocks shows positive values of matrix, and red blocks shows negative values of matrix. Malicious across malicious block shows true positive value, same for normal, and normal across malicious shows negative values. The accuracy depends on how efficiently it classifies values, gives across that rows and columns. 2. Multi-class classifier. Multi-class confusion matrix gives values same like green for positive and red in negative values. Only thing changes in multi-class is that it give very large number of values for each class and very difficult for manual calculations of parameters. The complexity of formula for multi-class confusion matrix is increased as compare with binary confusion matrix. DOS across DOS having positive values and other all values are considered as negative for DOS class, same for other class. 7. Conclusion. This paper proposed long short-term memory algorithm for intrusion detection in network security based on anomaly detection. The method comprises binary as well multi-class classification for detection. Multi-class categories attack into 4 main types which are including in NSL-KDD dataset. The need for detecting attack very precisely can be fulfilled by using deep learning method for intrusion detection. This paper gives 99.2% accuracy for binary classifier and 96.9% accuracy for multi-class classifier. Different parameters calculated to see model effectiveness for detection of intrusion like sensitivity is 99.26%, 99.26% specificity and 0.97 false positive rate. By using an algorithm of deep learning in MATLAB 2019b software, intrusion detection can be done more effectively in network security. Acknowledgement. I would like to express my gratitude towards the mentor who inspires me for taking this subject for a research, and also thankful to the Electronics Department of Government College of Engineering, Amravati, for provided facilities, environment and support.